Also, I would like to ask, does anybody have a question from the things we did last week concerning the course? Do you have a question? Okay, so I'll assume that you don't have a question. So as a quick recap, let's just recap what we did last week and what we did last time. So last time we said that for software engineers, it's important to have the knowledge of algorithms. We said our problems would be solved if we know how to represent our problem and then apply an algorithm to the problem. We defined that algorithm is not code. And because algorithm is not code, getting an algorithm does not mean you have started to write a program. No, it does not mean you have started to write a program. So we said after this stage of algorithm, then we move to the stage of programming. So what could algorithm be? Algorithm could be description in English of how to solve a problem. Also, we said algorithm could be a flowchart that tells you what to do. So we had example of an algorithm. We discussed the Euclid's algorithm for finding the GCD of two numbers. We demonstrated that we practiced it with two large numbers. And again, I explained it to you with two small numbers. We were able to establish the consistency of the algorithm. And with that, we could establish the definition of algorithm. We said algorithm is a finite number of clearly described and doable steps. So the steps should be a finite number. You should be able to count how many steps are in the algorithm. Now, these steps must be sensible steps. They should be doable steps. And we gave an example that you cannot have a mathematical step that divides by 0. It's not a doable step. That can be systematically followed. It means anybody who sticks to how you did yours should be able to get the same answer. People should be able to follow you and get an appropriate answer. And the answer should be a right answer. It's not an algorithm if it gives a wrong answer. And also, it must finish within a specified amount of time. So we discussed this the last time we met. All right. And also, we talked about the numbering system. From the numbering system, we moved to the hardware component of the system. We talked about the CPU, how it is provided service by the main memory. And we said that the main memory is small, it's volatile. So it has to get its information from a place that is large and non-volatile, which is the secondary storage. So the secondary storage sends information to the main memory. The main memory in turn sends information to the CPU. And I explained to you why we need the main memory. Because the main memory is fast. This is the reason. It's faster than the secondary storage. Now we have to connect keyboard and mouse. We have to connect our flash drive. That is where we get the input and output devices. They are used to give input to the computer and also to get output from the computer. But with everything, we have not described how they are connected together. Okay, the CPU is different, the main memory is different, secondary storage is different, but they are not connected to each other. How do we connect them? The bus. So this bus is the line that joins any component together on the computer. So we discussed this and then we move to syntax. The syntax are the rules that define what is acceptable in a programming language. So if you violate any syntax rule, you should expect that your code will not work. It will give you an error. On the other hand, semantics only define meaning. So it means that you could write a code that would work, but it would still be semantically wrong, which means it would work, but it may give you a different answer from what you're expecting. The answer it gives to you could be wrong. And I also gave an example of this using average. All right. Then we talked about program translation. We said that the CPU works only with machine code, binary instruction. But human beings don't want to write machine code. It is too difficult. So what do? We get a translator. So the translator understands our own language and it also understands machine code. So the job of the translator is to help us to convert our own language to machine code. Now, what is our own language? This is high-level language. High-level language. Our own high-level language. Like C. C is not in machine code. Usually C is in English. Like C++, like Java, like Python. So all of these are high-level languages that the CPU cannot understand. But somehow, we would prefer that the CPU understands that because we don't understand the language of the CPU either. It's too difficult. Okay, so then we get a translator that helps us to convert C to machine code. When it converts C to machine code, then the machine code is sent into the CPU for execution. It converts C++ to machine code, converts Java to machine code, converts Python to machine code. So this is the job of translator. Now, we said that we have different types of translators. We have two types of translators, the compiler and the interpreter. The compiler takes all the code and converts it into machine code directly, all the code. So it makes a binary file out of your normal source code. But on the other hand, you have the interpreter. This does not take all the code. This takes line by line. So with this, you can test a program that you have not completely written. So it takes the first line, converts it to a language that can be understood by the CPU, and then gives a result. If it was successful with the first line, then it comes back to take line 2. Takes line 2 and sends it to the CPU. So this is how interpreter works. Okay, so this is a demonstration. Let's assume this is C code. C code is converted to machine code. How? Using a compiler. This is the C compiler. So the C compiler converts the C source code to machine code. By the way, we will deal with C programming. So you will see a number of C codes. I believe starting from today, you will see C codes. So most probably by next class, we will meet in the lab. All right. So here is the CPU that now can understand our machine code. On the other hand, this is the demonstration for interpreter. It takes one line at a time, sends to the CPU. The idea here is that there's an interpreter that works hand in hand with the CPU, but actually it sends the message to the CPU because the CPU is the only brain in the computer. No interpreter is a brain in the computer. So it's the only let's say it's the only hardware brain in the computer. All right. So the job of the interpreter here is to understand the code from the source code, convert it into a language that is similar to what the CPU can understand, add its own interpreter code, and then get the CPU to give the result. Okay, so we discussed qualities of good algorithm and a number of other things. So I think this is quick and good summary in 10 minutes of what we did last time. So does anybody have a question while I switch to the new slides? If you have a question, I'm here, I'm listening to you, so we can get on our way. All right. So if you say you don't have a question, who am I to force you to have a question? So we move straight to C fundamentals. So this is what a C code looks like. We have here about 6 lines. This is the first line. By the way, we have line numbers in programming. This is the first line, the second line, the third line, the fourth line, the fifth line, and the sixth line. So these are lines 1, 2, 6. So we can store this code in a file named pon.c. Okay, let's not really care much about pon. Let's care about C. So what this is telling us is, now that you're programming in C environment, you should know that the extension of your C code would be .c. This is important, so that whenever you are trying to save your code, you don't have a problem. The name doesn't matter. Okay, yes, the same thing we said, but the C extension is what we need to always think about. Now, if you look here, you see that you have a number of uncommon lines. Most importantly, this line 1. It starts with a hash, which is not a normal thing in programming. So let's discuss the lines of code. All right, Tala and Umar, come back to class. Yes, welcome. So before a program can be executed, we have 3 important steps. So when you type your code and you click run, which I will show you very soon in case you haven't seen it before, the first thing that happens is called pre-processing. In pre-processing, the compiler looks for any line that starts with this. And by the way, the lines that start with this usually are the first lines in the code. Usually, they are the first lines. We may have more than one, we may have 5, 6, 7, as many as we need for our code to execute, but they must be the first lines. They must be the first set of lines. So they must follow each other. And by the way, they must always be one per line, one on a line. Okay, so the preprocessor obeys commands that begin with the hash, which is also known as directives. So what does this mean? When you click run, the compiler, through the preprocessor, comes to this line and says, okay, we have a hash starting this line. What are we asked to do? It means in the code you will see from here down, we need stdio, but we did not write the code of stdio anywhere here. So when you want to run this code, please look for stdio from the computer and add it to this code. That is the meaning. Hash include stdio.h means that whenever this code is about to run, look for a file called stdio.h. .h means it's a header file. It's a header. So look for a header file called stdio and then add it to part of this code because this code needs it. That is just the meaning. Now, who wrote stdio? It is not us. stdio.h was written at C company. It has been predefined from the company as a header file that provides us with input and output. So I means input, O means output, std means standard. So stdio.h gives us standard input and output. So without adding this line to your C code, you can never give a output. So whatever code you write, no matter what the result is, you cannot display it on the screen. That's the meaning. Onur, do you have a question? Onur, is he awake? Is he sleeping? Do you have a question, Onur? Okay, I think there's my answer right there in the chat. Okay, Onu has no question. That's great. It seems Onu understands what we are doing. Omar, please come back to class. All right. So let's continue. If you understand, then we continue. So we have solved the header files. Next is compiling. The compiler then translates this. Oh, okay. So the compiler This should be removed. Then translates the program into machine instruction, which is the same thing as the object code. So this is the .o file. So when we execute the compilation process, when we begin the compilation process, the first thing that happens is the header files are imported into the code so that they can provide input and output or whatsoever the header file does. And the next thing is we compile everything together to form an object code. Next is we combine the object code that is produced, this object code, with another additional code that is needed to yield a complete executable program. Okay, the next thing is this. Whenever we want to compile a program, we need to understand that the computers are different. The hardware of the computers are different. And because the hardwares are different, the way the computer will treat each code is different because there is something called operation code, the opcode. So the opcode of each CPU is different. So it means that the meaning of plus is different on different computers. And because of this, we have the final stage, this is the linker, where extra items that are required, extra code that are required to generate a code that can actually work on the CPU, then is added. So we do pre-processing by identifying headers and adding their code to the main code. After adding their code to the code of our file, then we compile everything together to form an O file, the object code. After getting the O file, which is the object code, then we link it with some extra code that is required to execute our program on that computer. So this is what we have. And now, where do we write our code? We write our code in an IDE, Integrated Development Environment. Now, why is it called IDE? It's called IDE actually because in the early days of programming, we didn't have IDE. In the early days of programming, we had different things. We had editor, and then we had compiler. Is there anybody who has used Linux before? If you have ever used Linux, probably for programming, especially for C programming, if ever somebody has shown you what it looks like writing C code on Linux, then you will understand this somehow. Because in most environments, to compile C code, you have to do this in terminal in Linux. So what do we have? In the olden days, we have an editor, which is like, let's say, a text processor. Usually, there is one called Edit. There's another called Nano. I think Nano is still prevalent till now. There are many. So you open Nano and you type your code. You really must trust yourself. So you type your code, you save it as a .c file, and then you begin to pray that your code works. What then do? You close the editor, you come back to terminal, and then you look for the path of the code. Where you stored the code, you find it in the terminal, and then you execute it. You write something like, oh, GCC space minus O space your file xxx.c and then xxx. So it compiles your file from .c and creates an executable for you. That was in the olden time. But that's too difficult. Who wants to type a code in an editor, in a text editor like Notepad? Actually, yes, Notepad is also a good example, Notepad. So who wants to type code in Notepad and exit Notepad to a terminal to execute? You can't even identify if you have an error while you are still typing the code. So it was really difficult to write code in those days. And so intelligent guys brought the two of them together. So they added the editor and the compiler together such that we can have what we call something called syntax analysis. As you are typing the code, the compiler is checking your code if it is correct. If you have a place where there is error, some places, in some editors, it underlines it with red. And that is what we call the integrated development environment, where the editor and the compiler are brought together as a single program. So in it, you can edit your code, you can compile your code, you can link, you can execute, you can do everything. You can debug without moving from editor to compiler and then from compiler to editor and roundabout. All right. Any question? It's strange that you claim that you don't have any questions. I hope you won't have questions in the exam. It's quite unusual that you don't have questions. Okay, because I think you should have questions. All right. So, what do C programs look like? C programs have this structure, this general structure. First is that C programs start with directives. This is hash include stdio.h. This is the example we saw earlier. The hash include stdio.h. This is directive. After directive, we have this main function. We call this the main function because its name is main and it's a function. Okay, you don't need to know what a function is now, but I'm very sure in the next 2 weeks you'll be professionals at functions. So this is called the main function and this is called the directive. By the way, this is not what all programs will look like, but this is the smallest thing you can have in any program for it to actually be a sensible program. You cannot have any program without the main function because the main function is the most important part of any program. And also, to do to write almost any complete code, you would need at least one directive. Not compulsory, but you would need at least one directive. Okay, so let's go back. Let's see something. Now, in the main function, we have two important things. We have two important braces, the curly braces. What do these braces do? These braces, we say they define scope. These braces tell us that this is the beginning of main and this is the end of main. Anything between these two braces belong to main. That's the meaning. So it says this is the name of the function. It's called main. And any code that belongs to main exists between these two braces. Please observe the direction the braces face. So C uses this and this in much the same way that some other languages make use of the keyword begin and end. Even the simplest C program rely on three key language features, which are, like we said, directives, first thing, functions, at least the main function, and the main function should have at least one line of code, and that one line of code is a statement. If you have more than one line, then you have statements. Before a C program is compiled, it is first edited by a preprocessor. Commands intended for the preprocessor are called directives. So these are directives. We already talked about them. And we said the first stage in compilation is preprocessing. So the preprocessor comes and looks at these guys and find the file called stdio.h to add to our code. All right. stdio.h is a header file. We said this earlier. We said .h means it's a header file containing information about C's IO library. I for input, O for output. So this is the library that provides us with input and output support in C. Without this library, we cannot get input from the keyboard into our code. We cannot get output from our code onto the screen. Directives always begin with the hash character. This is important. Directives always begin with the hash character, and they are always one line long, which means you cannot write two directives on the same line. This is important. You don't use anything to separate directives, just that you must write them on separate lines. Then we have function. Remember, we said that we have at least three parts in any code. We have directive. Remember, that's what we said. We have directives, we have functions, and then we have statements. If we go back again, we see them. We have directives, we have functions, and then we have the statement in the function. So these are the things we're explaining now. We just explained the directive. And then here is function. A function is a series of statements that have been grouped together and given a name. This is important. Okay, because you don't know statement yet, I would rather say it's a series of code. Or maybe better still, I would write a group of codes. Okay. So at least if you don't know what statements are, you know what code is. So a function is a group of code that has been grouped together and given a name. That is just the simple thing. It must have a name and it must be grouped together. Okay, how do we mean that? Let's come back to our example. Okay, I think it's time to wipe this slide. Yes. What do we have? We have this as a function. And we said the definition is that it's a series of code that have been grouped together to have a name. So where is the grouping? This is the grouping. This groups all of them together to form one single thing. Where is the code? Anything we write in between this place is the code. Here we just wrote statements to represent it. So a series of codes, which should be here, that have been grouped together and have a name. This is the name and have a name. So this is the name for our code, our function, by the way. At the same time, is the name for all the codes in this function. Because by this name, you can make use of the code. All this code have been grouped together between these parentheses. All right. Again, so we said a function is a group of code or series of statements that have been grouped together and given a name. Library functions are provided as part of the C implementation. So we have some functions that we call the library function. These functions already exist in C from the factory. We call them library functions, which means they provide some functionality to us. Okay, let's look for an example. If you look here, this is a library function, this print statement. The printf is a library function because it's a function that does a job, but it has been provided for us right from the factory. We just type it and we make use of it based on the manual. The manual tells us how we can use printf. And again, as we said earlier, printf is dependent on this guy because this is O is output. Printf is trying to display on the screen. So printf cannot work if you don't have stdio header. Okay, it gets more interesting. Let's continue. So a function that computes a value uses a return statement. So if you have a function that does some calculation and it was sent to do that job, this is important. If we have a function that was asked to do a job, then normally when it finishes with the job, it must tell what the answer is back to who sent it. This is really important. I think it's a nice way to explain functions. If you have a function, we say a function is a group of code that has a name, and okay, maybe I can expand the definition. Also, it has a job. It has something it does. So if it has a job, okay, let's add it to our definition. It has a job. So there is something it does. You just don't have a group of code that is meaningless. It's a group of code that has a name and also does something for us. Now, when it finishes its job, it needs to return the result back to somebody who asked it to do the job. And this is where the return keyword comes in. So the return keyword assists a function to send back its answer when it finishes executing. So here, whatever function has this line, when it finishes executing, it will return x plus 1. So if let's assume x is equal to 5, this line would return 5 plus 1. So this line would return 6. So where does it return it to? Back to whosoever asked it to execute its job, whoever called its name. So we want to look at an example of function, the main function. Omar, are you there? I want to be sure that Omar is not in Migros. Omar, are you there? Great, great. All right. Thanks, Omar. So let's continue. Okay, you are checking your lecture notes. That's good. That's good. That's good. Okay, please, it's good that you check your lecture notes, but if you find a question, ask me immediately so that you don't get confused. You don't mix things up in your mind. If you have a question, that's why you paid for summer school, so that I can explain to you. All right. The main function is mandatory. I told this to you earlier that there is no C program that you can write that will not have a main function. Okay, as we continue, I will teach you that you can also create functions. You can create a function and call it Farouk, whatever you like. It will work. But it does not matter if you create 1,000 functions. You must have main. You must have main inside of your program. You must have a main function. Without the main function, every other function you have created is waste of time because it will never work. Let's explain this slide. From this slide, you will know why. Now, the main function is mandatory. It is compulsory. You cannot remove it. Now, the name main is special. You cannot write it as oh, what's wrong with my mouse? It doesn't want to type. Okay. You cannot write it as main like this. Observe. I hope you can see the difference. The M here is capital. No, it is not accepted. It is not accepted. It must be M-A-I-N, not Turkish A. It is M-A-I-N. It is compulsory. Nothing must be changed in this name. It must be M-A-I-N. All small letters. It's special. It gets called automatically when you execute your program. So here is what happens. After you finish typing your very beautiful code and you want to execute the code, when you click run, what happens is the compiler does what we said it would do. The compiler does what? It does three things. First is it looks for the directives to do pre-processing. After doing pre-processing, then it does compilation to generate the .o file. And after doing compilation, what's the last thing? It does linking. It links with some extra code that are required. At the point of compilation, it looks for main. That's the first thing. At the point of compilation, after processing the directives, the next thing the compiler looks for is main. If it cannot find main, it stops immediately and you have an error. So let's say we did our work very well and it can find main. So it executes main and executes every code of your work. If it was successful, it must return a value called 0. Now, when the main function executes successfully, it normally should return 0 back to the compiler. This is important. And that is why, let's go back to our first code. The last line of our first code is return 0. Observe that it is main. So whenever the main function completes execution, it returns 0 back to what? To the compiler. This is important. All right. Now, if there is no return statement in the end of the main function, many compilers will warn you that you are creating a danger. Because if you don't make return 0 as your last line, there is no way the compiler will know that the main method or the main function has completed execution. There is no way it will be able to save memory. So some compilers will warn you. Actually, some compilers would never run. Some compilers would never execute your code if you do not end it with the return statement. If I am right, I think there's a programming environment, there's an IDE called Visual Studio, not Visual Studio Code, Visual Studio. Visual Studio is very sensitive. If you don't write everything in the perfect way it should be, it will never execute. All right. Statements. So we got to the last part, the third part of the basic components of every code. And the last thing is statement. We said we would have directives. We said we would have at least the main function. And inside of the main function, we must have statements. So here are statements. Statement is a command to be executed when your program runs. So statement is the code that you want to run. So if you look at our example, Ponzi uses only two kinds of statements. One is the return statement, and the other is the statement that shows print this. So these are the two statements. So the return statement and the other is the statement that prints on the screen. But remember, I told you earlier that this is a library function. And so because it is executing this line, it is called a function call. It is trying to call a function. Okay, you will learn how to create a function. But when you are not creating a function and they are trying to use a function, we say you are calling a function. If you are trying to use a function, you are trying to call it. That's what we say. You are saying you are calling a function. So here, our code pon.c is making a call to the printf function. Asking a function to perform its assigned task is known as calling the function. C requires that each statement end with a semicolon. Okay, so C requires that each statement ends with a semicolon. Again, observe, statement is not directive. Directive does not end with a semicolon. Directive just stay one line at a time. So, other than directives, C expects that normal statements, with an exception, we'll show the exception now. Normal statements must end with a semicolon, except for what we call the compound statements. Let's go back. I'll show you what we are talking about. Yes. So let's wipe our screen again so that you can see what's going on. Now, we said C requires that every line ends with a semicolon. But we said there are two guys that do not have semicolon. Why? Because by the way of their definition, they don't need you to say this is the end. Example is directive. We said directives must be one per line. So you don't need to end it again with a semicolon. The compiler already knows that one is on a line. It cannot spill to two lines. Two cannot be on a single line. So the compiler already knows that a directive ends at this place. Essentially, not actually ends at the greater than sign. The directive ends on this line. So when it gets to the end of the line, it doesn't find anything except empty space. So it knows that this is the end of this. It does not need a semicolon. Next is this line. This line is the definition of a method, the definition of a function. Also, we call it a compound statement. Why? Because this statement, actually, this is not the end of it. This is the end of this statement. And because this statement actually ends in curly braces, we believe that there's no reason to tell the compiler that this is the end, because this is not the end. The end is this curly braces. And also at the same time, you look at the curly braces, there is no other place where we find curly braces around. Curly braces are not just part of code that stay anywhere. So the compiler already knows that wherever I find these curly braces, it is the end of the first opening curly braces I saw, which is the end of the main function definition. So easily, the compiler can identify the end of compound statements. And the end of compound statement usually is their curly braces. So this is why these two are exceptions. So we won't have, let's erase this so that nobody gets confused by watching the video later. So we won't have end of line at the directives and the compound statement. Compound statement because it is immediately followed by its statement is inside of curly braces. That's why they are compound statement. All right. Directives are normally one line long, so they don't end with semicolon. Printing strings. So if you look again in the program, we said, in the first program we have been checking, we realized that we have the print function. When the print function displays a string literal, which is characters enclosed in double quotation mark, it doesn't show the quotation mark. So let's go back to our print. Look at the print. So when we execute this, our C file, it runs this line. This line has set of text that are inside of this quotation mark. They are inside of this quotation mark. So anything inside of this quotation mark is a string. Probably you should know that. What is a string? Okay, we will explain that very well later. But anything that we put as text, whatever it is, in fact, it could be number, we could have 7, it does not matter. As long as it is in between these quotations, we call it string. Anything within quotation is called string. Right. So printf doesn't automatically advance to the next output line when it finishes printing. So to make printf advance one line, include the /n at the end of the string. Okay, I think you need a break. Let's have 10 minutes break and we resume back from here. 10 minutes break. So, okay, let's make it 12 minutes. We come back by 10. So if you are still drinking chai, probably you should speed up your chai experiment. It's time for us to resume our code. Okay, during the break, I was looking at the chart and I could see that Talha asked the question. Talha says, what is the difference between print line and print F? All right, Talha, it seems you are learning Java or you are trying to do something with Java. Print line, system.out print line exists in Java. We don't have print line in C. What we have is printf and puts. Okay, you don't need to think about puts now. Hopefully, we will get there. Most probably, we will never get there. But puts and printf are the only tools that we have for display in C. Print line is clearly from Java. That's the common language that uses print line. Other languages use it, but not C at all. All right. Tala, are you learning Java? Or do you have something to do with Java? Okay, let's forget about that and continue. So printf doesn't automatically advance to the next output line when it finishes printing. So to make printf advance one line, you have to include this /n. /n is called the new line character. Okay, I'm thinking it will be easier to explain this to you with an example. Let me open my dev C++ and okay, let's write a little code hash include stdio.h int main return 0 as usual. So we can say print f we are here. Ways. Yes. So if you look at this code, there's an error. What's the error? Who can find the error? Anybody can find the error? Ooh, ooh, ooh. Yep. Oh no, thank you. So at the end of this line, we should put a semicolon. Why? Because we said statements must end in semicolon. It's pretty straightforward. So let's execute our code. We can compile and run. Um, let me, yes, let me save here as, let's say, chapter 1 code. We have to change this to .c, remember. Okay, so this is C, chapter 1 code.c, so we save. Now the program tries to run. I'm sorry, my antivirus will take some time. Yes, so here is what we have. We are here. But what are we trying to explain? We are trying to explain the fact that printf doesn't automatically advance to the next line. So let's try something. We are here, and then printf, we are still here. All right. So let's increase the size of our code window so we can see everything. Now we run again, and I want you to see what will happen. What is happening? We are here and we are still here, are both mixed together on the same line. So this is the problem. We said the print function does not advance to the next line by itself. You have to force it to go to the next line. So how do you force it to go to the next line? Our slide says we use the new line. We use the new line sequence. So we use this slash and n. This is what we call the new line escape sequence. Okay, let's check our slide. So we have to include the new line. Observe where I put the new line, not here. If you put it here, you'd have your code crash immediately. Okay, let's try it. Why not? Let's try it. It's not bad to have errors. Okay, can you see? It's wondering. It says, what is this slash? This slash is in a very strange place. We don't know what you're trying to do. Actually, instead of having this slash, we're expecting that your code will end. We are expecting that you will have the end of the printf. That's the meaning. So let's remove the guy, and now life will be fine. Okay, we run the code again, and things look immediately different. Can you see? We are here, we are still here. Any question? Okay, let me remove the result so you can at least look at the code. Any question, please? Any question? No. Great. So let's continue. To make printf advance to another line, use /n in the string to be printed. Again, in the string. This is important, in the string. So you put it inside of the quotation, inside of the string. On the other hand, if you move it elsewhere, it would work at where you move it to. So if you move it here, it's going to print these two exclamation with this part of the string, and then move this guy to the next line to go and join this. Okay, let's try it. So what do we have? Exactly what we expected. As long as it's in the string, it works in the string. Okay. The statement to see or not to see, this is the question, could be replaced by two printf calls. Okay, what this means is, since we know that if we don't put /n in a print statement, the statement would print as just a single line. We can do the opposite. We can reverse this idea to actually print two print statements as just one line. So here is what we are saying. We are saying, even though if I want to print these two as a single line, by removing the /n here, the two of them become one line. So I can say something like we are, where is my mouse? We are still here. So, because we know that printf does not implicitly by itself move the cursor to the next line after printing a statement, we know that if we print these two print statements, they will give us one sentence. The two of them will be on the same line. So we can use this to solve the problem of screen width. If you are typing a print statement and it is longer than the screen and you don't want to reduce font size, you can do this. So let's try it. You see that everything will be on one line. So here is it. We are still here. Okay. So also the new line character can appear several times inside of a single print statement. Next, comment. Sometimes you write code and you want to write explanation inside of the code because it's difficult for you to write code, let's say 50 lines, and then you get another book and in the book you say line 1 is used for this, line 4 to 5 is used for this. It's difficult. It means you have to look at the book and the code. But a better way is to write this explanation inside of the code. Write the explanation inside of the code. That way you can read the explanation. But at the same time, it's going to be difficult to just write the explanation as part of the code. I can say here we start and here we end. Now, this looks okay. We are explaining what is happening in line 4 and line 5. But the problem is that when we run this, the compiler would try to execute what is after the semicolon as a new line. And because it cannot understand what I mean by here we start, it's going to give me an error. It says, what do you mean? I'm expecting any of this, not that you have here we start. So what do we do if we really want to write comments? The simple way is one line comment. We put 2/. Can you see the color change? So one line comment by putting 2/ is fantastic. It helps us to make comment for one line. And it's the same thing here. One line comment. If you run the code now, everything looks well. The code will work. So where is it? Yes, the code works. But at the same time, we can have a range comment, not just one line. We can comment an entire range. So we can say, yes, this is the code with which I teach Tala how to write C programs. Yeah, I am teaching Talha, and okay, let's move to the next line. His friends, or let's say his nice friends, how to move to the next line. Code in the lovely C language. Remember, everybody loves C. Now, what did I just do? I just commented this part of the code. But the problem is that if you look, everything is blue, which means everything is a comment. So what do I do to solve that? I must mark the end of my comment. How do I mark the end of my comment? By using the opposite of how I started it. The opposite of this, which is the star comes first before the slash, star slash. So this way, I have done what I call range comment, range. So anything between this and this is seen as comment. Okay, let's run the code. We run the code now. Everything works well, but anybody who looks at our code some other time later can still understand what is going on. Okay. So if you forget to close the comment, you'll have a trouble because it sees this as the opening and then it's looking for the closing. It cannot find closing. It finds closing here. So this would be the closing for this. So everything here will not work. Will be considered as part of the comment. Okay, so here is another way to do comment. You already saw this. I demonstrated this to you first. You can have comment using double slash. This is safer because it comments only one line. So you cannot have a mistake of not closing the comment. Variables and assignments. Okay, before I go to variables and assignment, let me ask you, please, do you have any question? Any question? Any question at all? Anybody with a question? No question. All right. Okay, most programs need a way to store data, at least temporarily, while the program is executing. And these storage locations are what we call variables. So you want to store information. If you look at our code, in this code, we are not storing anything. We are just printing, we are here immediately. We are printing still here immediately. We are actually not storing them anywhere. We are just taking them as text and showing them on the screen. But there are times we want to actually store them somewhere in the memory of the computer. Whenever we store them in something called variables. Why? Because we can change it. That's why we call it variable. So that takes us to types. Because if you have a variable, you should remember that we can have different types of variables. Mathematically, this is called an integer. Mathematically, this is called a floating point. This is a float. So if we know that this is a float and the first one is an integer, it tells us that already we have at least two types. This is one type, integer. This is another type, float. Again, we have other types. We have a. A is not an integer. A is not a float. A is a char. It's a character. So this way, in C, we have different types. And so whenever we want to create a variable, we must be able to tell the compiler that, okay, right now, we are creating a variable, and this variable will hold this type of value. So if we are creating a variable that would hold integer, we have to say, okay, this variable is called an integer variable. Okay, let's continue. Each variable must have a type. C has a wide variety of types, including integer and float, which you already saw. A variable of type integer, int, short for integer, can store a whole number, such as 0, 1, -5, 10, but it cannot store decimal point. The largest integer value is typically something like this, but can be as small as whatever we like. It can be as small as 5, can be as small as 1 -5, whatever it is that we like. But the key thing is that it cannot have a decimal place. It's no longer an integer if it has a decimal place. All right. Also, we have float, which is called floating point. After studying the integer part, we still have some other values we may want to store. So after storing the integer part, the float also proceeds to store the floating point part. And obviously, we know that it would need extra space. That is why we say it is much larger than integer, because it needs space for the floating point. Also, a float variable can store numbers with digits after the decimal point. So it can store numbers with digits after the decimal point, just like what we have here. It can store number including the digits after this decimal point. If you try to store this in an integer, in an integer variable, you will be making a mistake. Why? Because integer variables would not store this part, because it cannot store after the floating point. Okay, what is the disadvantage of using float? It is slow. Also, it is an approximate. It's an approximate. Okay, in some cases it is not approximate, but in many mathematical cases it's an approximate. Is there anybody who can think about why we say float is an approximate? Anybody? Anybody who can think to tell us why float is an approximate? Okay, let's take, for example, what is 21 divided by 7? What is 21 divided by 7? Anybody awake? You are sleeping, you are not sleeping. Let me know. What is 21 divided by 7? I mean, what is the answer? What is the answer? What is the answer of this mathematical expression? 3, 3. Thank you. Nice. It's 3. So it makes sense. It's 3. So if you try to store this inside of a floating point variable, it's simple because the answer we know to this is 3 point, as far as floating point is concerned, is 3.0. I believe you get this. This is simple. But now let's look at pi. If we try to do 22 over 7, what is the answer? This is mathematically infinite. If we try to do another thing like 10 divided by 3, what is this? It is impossible because the answer is 3.33333. It's forever. So what do we do? If we try to store this inside of a variable that is a floating point variable, it's impossible for a floating point variable to store 10.3333. The 3 doesn't have an end. But the problem is that inside our computer, our memory has end. So no matter how large the memory is, by the time it takes 3 trillion, 3 billion threes, it's going to get full. So the computer is going to crash. So what do? We set limit. We say, okay, we cannot take all the impossible threes in the world. Whenever you store up to this specific number of values after the decimal point, cut the rest away. Just forget about the rest. And that is where we arrive at the notion of approximate. Because at a point in time, we will have to cut the rest away. So that's why we say, if you want to store 22 divided by 7 in a float variable, it is approximate. We cannot store all the digits after it. Probably before I proceed away from this slide, let me just show to you with calculator in case you didn't grasp what I'm saying. If we say 21 divided by 3, what is this? It's simple. I mean, 21 divided by 7. 21 divided by 7 is simple, it's 3. But if we say 22 divided by 7, even the calculator has a problem because the digits are too many. It just has to cut it somewhere. And so what the calculator is showing is not actually the real value of 22 divided by 7 because there are still values after this 3. It cut it, and that is why we say it is showing only approximate value. And that's the same problem with the computer's memory. Now, variables must be declared before they are used. This is important. And how do we declare variable? This is it. So this is the variable name, and this is the variable type. The variable name is height, and it's of type integer. The variable name is profit, and it's of type float. Alternatively, several can be declared at the same time. So here we are defining one variable and then another variable on separate lines, but we can actually define variables of the same type. Observe, of the same type on the same line. So by executing this, we create 4 variables: volume, width, length, and height. All of them can take integers. On the other hand, we can do the same for floats. All of them can take floating point values. When main contains declaration, this must precede the statement. So in the main function, when you declare variables, you should declare the variables before you try to use them. You cannot use a variable and then you declare it. I mean, even to us, we know it doesn't make sense. So we declare the variable and then we try to use the variable, not we use the variable before declaring it. All right. A variable can be given a value by means of assignment. Okay. Now that we have created our variable called height, we have created a variable called height. But what is the value of height? Nothing. We didn't put anything yet. So when we want to put it, how do we put a value in it? We use the assignment operator. You put the value at the right-hand side of the assignment, just like mathematics. But this is not equal to, please, this is not equal to. Something else is equal to in C programming. Here, this is what we call the assignment operator. We use this to assign a value to the operator. I've used it to assign a value to the variable. So we assign 8 to the variable. After executing this line, if you check the value of 8 of height now is 8. Before a variable can be assigned a value or used in any way, it must first be declared. Okay, this is again another thing. You cannot just say John is equal to 5. If you try to execute this, you would have a problem. Your program will not run. Why? Because you are trying to use John, but you have not created John. You have not told the compiler what is the type of John. So you must first have, let me change the color of the pen. You must first have int John. Then you have John is equal to 5. This will work. Or you can actually have int John is equal to 5 on a single line. But for the first time, you must write this int. The first time you're using the variable, you must write this int, the type. Okay. A constant assigned to a float value, to a float variable usually contains a decimal point. So if you define profit as float, like we have done here, float, profit is float. So whenever you're assigning values to it, the values should have the decimal point. I mean, it is expected that it has decimal point. But on the other hand, if you don't put decimal point, if you just say, let's say you write profit is equal to 7, actually what the computer will store is profit is equal to 7.0 because it must have a floating point. But it is better to put the value f after while you are assigning it to explicitly tell the compiler that this is a float. An integer variable is normally assigned a value of type int. An integer variable usually receives the value of type int. That means if you say a variable x is an integer, then normally what you should assign to it should also be an integer value, not a floating point. So floating point values normally are assigned to integer. We are not saying it is impossible to swap them. If you like, you can assign a floating point value to an integer variable. Something interesting will happen. You can assign an integer variable to a floating point, an integer value to a floating point variable. Okay, something interesting will happen. I think I already told it to you here that if you store 7, it will become 7.0. So something interesting will happen. If you store 7.5 inside an integer variable, what is the interesting thing that will happen? 0.5 is thrown away, so it stores only 7. I mean, this is the idea. Mixing types, such as assigning an integer value to a float variable or assigning a float value to an integer variable is possible, but don't always try to do it if you can avoid it. It is possible, but it's not always safe. So once a variable has been assigned a value, it can be used to do the calculation of another variable. So now that we have the values of these 3 variables, it is easy for us to calculate the value of another variable. But again, observe, we have defined all these 3 variables. We have defined them here. We have defined them. We are continuing from here. So don't think that we are using variables we did not define. We have defined them here. The right side of an assignment can be a formula, an expression, a value, a constant, a variable with operators whatsoever. What this means is this is the assignment operator. Anything on its right hand side, which is this side, can be an expression, which is what we have here. It can be just a value like what we have here. It can be another variable. You can say height is equal to, maybe we can say height is equal to width. This will work as long as there is a value in width. If there's no value in width, then you have a problem here. But if you have stored a value in width, let's say width is already 10 and you have not assigned height, then you can set the value of height to width. So this is, you are storing a variable. This is it. It could be a constant. This is it. But and also it could include operators like this. Printf can be used to display the current value of a variable. So if you have a variable and you want to know what value is in it, you can also display it with printf. By the way, we said printf is for displaying on the screen, so it can help us to display. So to write a message height h, where h is the current value of the height variable, we use the following call of printf. We can say height, this is a string, remember, and the string ends here, comma, height. Oh, what is going on? This height here is the variable height that we defined in the previous slide. So now we know there's a value in variable height. What else don't we know? What is this percentage %d? Percentage %d is called placeholder. Observe that it is within the string. Percentage %d is called a placeholder. It holds a place for the variable that is after this comma. So this comma is helping us to separate this string from anything that is here. So this percentage %d means it's a placeholder for height. So height is going to replace percentage %d when the code executes. Why d? D is for integer. D is for integer. We have a lot of them, but d is for integer. Okay, let me quickly demonstrate this to you before we proceed. So we can say int height is equal to 11. So now in this line, we can say the height is equal to what? 11, comma height. But there's a problem. If we run this code now, we have not put the placeholder for execution. So it's going to try its best to do what it can do, but it cannot know where to put the height value. So we have to put the placeholder for the integer, which is percentage %d. When we execute this code now, it gets the value of height and puts it in front of this assignment operator. So it says the height is equal to 11. All right. So percentage %d works only for integer variables. If you want to print floating point variables, use percentage %f, but it must be a floating point variable, remember. So if you put f now and you try to execute, it's going to print nonsense for you because height is not a floating point variable. Height is an integer variable. Okay, let's make experiment. Let's change height to float. So now we have height as float and things should look more sensible. So now it is 11.60. 11.60. All right, let's continue. So to force f to display p digits after the decimal point, put .p between percentage and f. Okay, it's easy to explain. Let's change the value of 11 of height. Let's say change it to 11.1234566. Or let's not use 1, 2, 3. Let's start from 3. 3, 4, 5, 6, 7, 8. Now, if I want just 2 digits to display after this decimal point, if I want only 2 digits to display, I would, between percentage and f, I will put .2. If I want only 2 digits, I will put .2. So what will display on the screen would be 11.34. Okay, before we do that, let's first test the normal situation. So percentage %f would show us exactly what we have. Exactly what we have. But if we want just 2 digits, we put .2f. So when we execute, it gives us just 2 digits after Any question after the decimal point? Any question? No questions. Interesting. Okay, I was expecting to have a question from this output. Now, you should wonder, why is it 11.35, not 34? What happens is, at the point of dot 2, we are trying to show 2 digits. It understands mathematics. C understands mathematics. So it checks the next digit. If the next digit is more than 5, then it does what? It rounds this guy up to 5. I mean, to the next integer. So let's do 4.1f. So it shows only dot 3. Observe that the next character or the next digit after 3 is 4, and 4 is not up to 5. So it will not be able to round 3 up to the next value. Let me run. See, it doesn't round 3 to the next value. It leaves it at 3 because the next digit is 4, and 4 is less than half of the integer range. Okay, let's change 4 to 5 and see what will happen to 3. We change 4 now to 5 and we run the experiment. And then we see that it rounds it up now. It rounds it up to the next value. So this is what happens. Here is what happens when we try to manipulate float display. Okay, so we put this and the 2f. Okay, now you understand this. There is no limit to the number of variables that can be printed by a single of printf. So we can print many variables using printf. So let's say float height is this, and then int length is equal to 40. Okay, so we can say the height is equal to percentage f, the length is equal to percentage d, because we know the length is percentage d. Let's remove 1f. Let's change it from 1f to 3f, and then we display length. Okay. Let me see. How long can it go? Okay, let's make it wider. Okay. Let's bring f back. Yes. So let's run our code and we see that the code works. Height is equal to this, the length is equal to this. Now, please make an observation. Yes, float gives approximate value. It's just approximation, if it can approximate or no. So what do we learn? We learn that height is 11.356, height is 11.355. Okay, it approximates. Height is the first variable. So what I want you to observe is this. This placeholder does not display height because it is float and height is float. No, that is not why it is displaying the value of height. It is displaying the value of height because this is the first placeholder in the string. This is the number 1 placeholder. This is number 2. If we have more, we can count 1, 2, 3, 4, 5. But we count from the left. So this is the first placeholder. The first placeholder, we take the value of the first variable. The second placeholder, we take the value in the second variable. And this is why we have the result. Initialization. Okay. Initialization. Some variables are automatically set to 0 when a program begins to execute, but most variables are not set to any value. A variable that does not have a default value and has not yet been assigned a value by the program is said to be uninitialized. So if you say int x and you didn't put any value, x is defined, but x is not initialized because there is no value. So if you go to the next line and then you say x is equal to 7, then you have initialized x. Attempting to access the value of an uninitialized variable may yield an unpredictable result. So if you are trying to print x when there is no value in x yet, you should expect an error. Percentage 0f, that's interesting. Did you see? 0 points after, 0 values after the decimal point. 0 value, 0 digits, better, 0 digits after the decimal point. With some compilers, worst behavior, even a program crash can occur if you try to use a variable that has not been defined. By the way, I'm using dev C++, and dev C++ is too nice. I mean, it's very nice for students. So even if I remove the length variable, the program may not crash. Oh, it stops, it crashes. That's nice. That's nice. No, actually, no, 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 no. This is not what I was trying to experiment. I was trying to experiment having a variable that is not initialized. Clearly, all programming languages will crash if you try to use a variable that does not even exist at all. So now let us run again. I don't expect dev C++ to crash. Yes, it won't crash. It just does something random for you. It does anything it likes. So we don't have length. You are trying to use length. Okay, no problem. I put my hand in my pocket. I bring a random length for you. That is what dev C++ has just done for us. So please be very careful. You could have this kind of error and never find out why you have the error, because sometimes the C++ behaves in a funny way. Okay, so some compilers would cause a crash. Some will just give us an unpredictable result. This is what we just got, unpredictable result. The initial value of a variable may be included in its declaration, so you can define the variable and also initialize it. Any number of variables can be initialized in the same declaration. Okay, we already understand this now, since we know how to do normal multiple variables initial, multiple variables declaration, so we can initialize at the same time. Each variable requires its own initializer, so you cannot say, oh, all of them are taking the value of 10. This is not right. I mean, there's a way to do this, but this is not the way to do it. If you want many variables to take just a single value, this is not how to do it. You cannot just separate them by comma. If you do this, only this guy who is assigned 10 will get 10. All the rest will stay not initialized. So, printing expressions. Printf can display the value of any numeric expression. The statement volume is equal to this, and then we can take the value of volume and display it inside of printf. We can do it by actually multiplying the expression inside of printf. When this multiplies, it forms just one result. So that one result will go into this placeholder. It's as simple as that. Any question? Any question? Okay, so if you don't have a question, I think I should stop here. I think I should stop here. So if you have a question, you can send to me anytime. I'll respond to you. You can send it through email, or if you like, you come to my office. We can see. So if you don't have a question, please write your name in the chat. Write I'm here, or write present. Write something in the chat so that I know that you are present. Your next lecture, I will announce if it's going to be online or if it's going to be face to face. I will announce before the class. All right, please write present, or write I'm here, write yes, or write something in the chat now before we end the chat and before we end the class. Thank you so much for being very cooperative today. Write your name in the chat, write something in the chat, and then see you next class. Tala, you're in Antalya for 2 weeks. Okay, so what do? We should not have our face-to-face class. Well, if we get to the point of practicing, what can we do? We will have our class, and we will hope that you join us very soon. We wish you a very nice holiday, Tala. While you are in Antalya, try to join us if possible. If possible. Well, okay, we'll wait to see you when you come back. All right, take care, everybody. Please, again, as I said, write something in the chat to show that you're in class. That is what I will use for your attendance. Take care of yourself. Bye-bye.